Today we're going to be looking at logarithmic and exponential equations, and we've already done some exponential equations a week ago today when we were solving equations using that same base stuff. Like you take the 25 and write it as 5 squared. Or maybe the 16, you would write it with 2 as the base. So think of 16 as 2 to the 4th. At the time, we were like, well, what would we do if there were no common base? Like here we could rewrite 16 as 4 squared and 64 as 4 cubed. We also did some problems with the letter E. E is the decimal number 2.7, 1828, 1828. I think the next one's a 4-6. And we said, okay, if you have an E on each side, that's the common base. The natural question to ask is, what if there's only one E? We're about to answer all of those questions now. How do we solve an exponential equation without a common base? So this is going to be, I should have already labeled this. Today we're looking at solving exponential and logarithmic equations. And the day I'm making this video, it's Wednesday in November. November is it 8th? No, 9th, isn't it? 2022. So, let me write a few sentences. To solve an exponential equation, we had said an exponential equation has the variable and the exponent. To solve an exponential equation in which there's no common base, solve an exponential equation of which there's no common base, here's what you're going to do. Step 1. Take the natural logarithm. That's the thing that's denoted with an ln. Take the natural logarithm of both sides. That sounds very involved, but in reality, all you're going to do is stick an ln in front of each side. But by doing that, you can then use the power rule of logarithms to carry down the exponent. Well, let's say exponents, because there's usually exponents on each side. That rule about logarithms. Let's see, where did I have that written? We had 3 logarithm rules that had names. The power rule, the product rule, and the quotient rule. The power rule said if you have an exponent at the end of a logarithm, you can carry it down in front. Once you've done that, solve for x. Solve for x. Let's make a note. Ooh, that pink is sort of hard to read. Let me just put my note in black. If there are 2 x's, isolate the x's or the x terms on the left, then factor out the x and divide. it sounds worse than it really is. Okay? So we're going to solve exponential equations where there's no common base. Starting with problem number 1. Notice how that problem, it's not like the ones that we were doing a week ago today. There's no way you're going to get a common base. There's a 2 and a 3. It's not like a 5 and a 25, or a 2 and a 16, or a 16 and 64. There's no common base. No way you can rewrite 3 as 2 to the power. So this is problem 1. Solve 2 to the x equals 3. Well, step 1 is to take the natural logarithm of both sides. By that I just mean stick ln in front of each side. So I'll put a blue ln in front of the 2x and in front of the 3. Now that I've done that, I can carry the exponent down to be in front of the ln. Okay? So move the exponent down in front. Put it in front of the letter L. So it's x ln 2 equals ln 3. And now we need to solve for x. We don't need to do the note, use the note here, because there's not 2 different x's. There's just one x. The operation that's going on here when you see an x and ln, since there's not a plus or minus between it, we assume it's times. So what would I do to both sides to get the x by itself? What would isolate the x? I'll give you a hint. Am I going to subtract ln 2 or divide both sides by ln 2? Divide, that's right. Treat the ln 2 as if it were just a variable. If you had xy equals something and you were trying to get the x by itself, you would just divide. So there. So our answer is ln 3 over ln 2. Don't think you can cancel anything at that point. Don't start canceling the ln and get a 3/2. The ln is a function, not a number. Let's look at the instructions. We haven't done a lot of decimal numbers this semester. It's a general rule of thumb. You don't use decimal numbers in algebra, or you use it very rare. This is one of those rare times. It says round to 4 decimal places as needed. Use a comma to separate answers as needed. Well, I don't think we're going to need to use a comma, but I need to pull up my calculator. Let me look back over here. In order to punch in ln 3 divided by ln 2, it's a little tricky. On this calculator, the ln is right here. Ooh, let me clear all of that. When I mash the ln button, notice how it opens parentheses. That's going to be the thing that causes trouble. If your calculator opens parentheses when you hit ln, you've got to make sure you close them. So since my calculator put the parentheses there, opened them, I'm going to write in the way I'm going to have to close them. I'll have to do this and that. If your calculator opens parentheses, you've got to close them. If you don't, you'll get the wrong answer. ln 3, close parentheses, divided by ln 2, close parentheses, enter. So we're told to round this to 4 decimal places. The wavy equal sign I'm writing just means approximately equal to. Do you ever see little wavy equal signs? That's just a way of saying we're rounding something. So we're going to round it to 4 places after the decimal point. 1.58. Then it's a 496. So we want 4 digits. Am I going to leave this at 40 or make it a 50? Yeah, 50. If the digit after the 9 is 5 or bigger, you round it up. So 1.5850. Who would have guessed? 2 to the 1.5850 power equals 3. 1.5850. Now, I think most of the problems in this assignment is going to have an option, something like this. The solution is not a real number, or it might say the solution is the empty set or no solution. That'll happen if you had a negative number after a logarithm. Like on this, if I type ln negative 3 divided by ln 2, we get an error message, non-real answer. Okay? As a general rule of thumb, you can't have a negative number after any sort of logarithm, not just a ln, but any of them. Okay? Oh, also, I wanted to show y'all, if I hadn't closed the parentheses, if I'd gone ln 3 divided by ln 2, would I still get the 1.5850? No. Okay? Make sure if your calculator opens the parentheses that you close them. Problem number 2. Oh, wow. You know what? Don't write that one down. I need to do something. I don't really want to do that one because you could do it with a common base. Odds of that ever happen. Here, this is the one I'm going to do. Here's problem number 2. The way that was a base of 2 and 8, that you didn't need to use logarithms on it. What I'm going to show here isn't the common base, but how to do it if there's no common base. So this is problem 2. 5 to the 7x plus 2 power equals 8 raised to the x power. Oops. Well, we start off by sticking ln in front of each side. Make sure that you always remember that's an ln and not an in. In the previous assignment, if you type a capital I instead of a lowercase l, it'll count it wrong. Okay? So I'm writing it cursive just to try to show it as a lowercase l, not a capital I. Now, step 2, bring the exponents down in front of the letter L. Okay, so we'd have 7x plus 2 times ln 5. All of that exponent should be in front of the letter L. That's why I have the parentheses there. Equals, bring in the 8. Then we have ln 8. Excuse me, bringing the x down. Then we have ln 8. This problem's a little messy because all of this needs to be multiplied by ln 5. That's why I have all of that in parentheses. So what we're going to have to do, this one's more involved than problem 1, distribute the ln 5 we'd have a 7x ln 5 plus a 2 ln 5. All you do to distribute the ln 5 is just stick it on at the end of each term. This is one of the things that's going to we need to use the note for. There's more than just one x. You see, there's two x terms. So we need to isolate the x terms on the left. So that means move the stuff around like this. I'm going to move this x ln 8 over to the left. And I'm going to move the term that doesn't have an x, the 2 ln 5, to the right. So we'd have 7x ln 5, then a minus x ln 8. This is a messy manipulation. Equals a negative 2 ln 5. So if there are two x's, isolate the x terms on the left. I've done that. Now we're going to factor out the x. That sounds much more involved than it is. To factor a variable out, just write the x down and two sets of parentheses, or in parentheses. And what goes in the parentheses is just, what do you have if you covered up the x? It'd be 7 ln 5. If I just covered up the x, it would be a minus ln 8. Now remember how you factor out a variable? If you need to factor out a variable from some algebraic expression, I factored the x from each term. What's remaining? A 7 ln 5 minus ln 8. It's sort of the reverse distributing. So we factored out the x and then divide. That's how we solve for x. So I'm going to divide both sides by all of this mess here. The 7 ln 5 minus ln 8. Okay. Now, to punch that into your calculator, it's going to be very, I don't want to word it. It's sort of messy. Think of this. 4 plus 6 divided by 2 plus 8. 4 plus 6 divided by 2 plus 8. I think y'all could all do this in your head. What would we get as an answer to 4 plus 6 over 2 plus 8? 10 over 10, which simplifies to 1. If I punch this into my calculator the way I have it written there, 4 plus 6 divided by 2 plus 8, I don't think we're going to get a 10. I think we'll get 15. Not a 10, a 1. We get a 15, am I right? Is it 15? What is the calculator doing? We know the answer should be 1, right? 10 over 10. Well, the calculator follows that order of operations. Please excuse my dear Aunt Sally. Since there's no parentheses here, it divides. 6 divided by 2 is 3, then adds it all together. What am I saying we need to do in order to get this to give me the right answer? Well, parentheses around the top and parentheses around the bottom. Then it does the parentheses, then it divides them, it gives you the right answer. In general, if there's more than one number on the top of a fraction, that numerator should be enclosed in parentheses. When I look at this messy fraction right here, there's 2 numbers. Put it in parentheses. On the bottom, there's 1, 2, 3 numbers. Put it in parentheses. Now, that's not all of the parentheses. On my calculator, every time I hit ln, it opens the parentheses. So that means after the 5, I'm going to have to put 2 parentheses. Same right here, it opened them, so I close it. After the 8, close it. And those parentheses are absolutely critical. If you don't put those parentheses there, it's going to give you an answer, probably, but the wrong answer, okay? Which I guess by definition is not an answer. Okay? Now, to punch all of this into your calculator, I start off parentheses, and this is a negative sign here. On my calculator, the negative symbol is right here. This is the subtraction key. Negative 2 ln 5. I've got to put 2 parentheses or it's going to give me the wrong answer. Divided by, this is what I'm about to hit is the first green parentheses. I'm right here. 7 ln 5. If I don't close that parenthesis around the 5, I'm going to get the wrong answer. Minus ln 8, close, close. On some calculator, if you don't put the parentheses at the end, it'll assume it's there. On others, it'll give you some sort of error warning. So, it's a general rule of thumb. Every time parentheses are open, you close them. And I think this one said round to 3 decimal places. Okay, we're rounding to 3 decimal places on this one. So x is approximately, we're rounding to 3 decimal places, a negative 0.3503. If I'm rounding to 3 decimal places, will I leave this 0 as a 0 or round it up to a 1? What do y'all think? Leave it as a 0? So negative 0.350. Negative 0.350. Any questions? I think number 3 is probably the most involved problem in this assignment. Number 3, let me write it down. 5 to the x plus 2 equals 3 to the 2x minus 2. 5 to the x plus 2 equals 3 to the 2x minus 2. Okay. Did I miscopy it? Let me move the calculator. That's sort of distracting right now. Well, can we get a common base? Well, no. If the 5 had been a 9, we could have used a common base. 5 to the x plus 2 power equals 3 to the 2x minus 2. Oh no. Well, okay, go through those same old steps. Stick ln in front of each side and carry down the exponent. Okay? So I'll stick an ln in front of each side. And then, oh, let me see. This, I'll blow it up a little. Why hadn't I thought of that? So stick ln in front of each side. Now carry down the exponent. So the x plus 2 goes in front of the letter L. The 2x minus 2 goes in front of the letter L. But both of those have to be multiplied by the ln 5. There. Now, we distribute the ln 5 just by sticking it at the end of each one of these terms. Oh, I messed up. This ln 5 right here, it should have been a 3. Now see, I'm going to make the correction in blue. Instead of that pink 5, it should have been a 3. Okay. So we have x ln 5 plus 2 ln 5 equals 2x ln 3 minus 2 ln 3. Now, since there's two different x values, we're going to need to isolate the x terms on the left, factor out the x, and divide. So, let me see. How am I going to move this stuff around? I'm going to do this. I'm going to move this 2x ln 3 to the left, so that's going to make it a minus 2. And over here, the 2 ln 5, I'm moving to the right, so it'll be a minus 2. So let me write it out. We have x ln 5, and then a minus 2x ln 3, and I'll go ahead and write the negative 2 ln 3 before the minus 2 ln 5. If you want to do it the other way around, negative 2 ln 5 minus 2 ln 3, that is perfectly fine. Now we're going to factor an x from each term. So just write x in parentheses. And just whatever's there without the x is what goes in the parentheses. It'd be ln 5 minus 2 ln 3 and divide both sides by all of this stuff here in order to get the x by itself. So divide by ln 5 minus 2 ln 3. Divide by ln 5 minus 2 ln 3. Got to have the parentheses around the top and the bottom. And we got to be careful with the parentheses around the LNs. Every time I hit LN on my calculator, it opens a parenthesis, so I have to close it. If I don't have this parenthesis right here that I'm pointing at, it's going to give me either the wrong answer or an error. Around this 5, this parentheses, that means I need 2 parentheses here and here. And if I don't punch in those 2, it's going to give me the wrong answer. Down here, where will I need parentheses? Well, there. every time I hit L in, it opens parentheses. Whoop. My first graphing calculator that I bought way before y'all were born was a TI-85, and that calculator, it didn't open parentheses when you hit L in. Okay? I remember the first time I saw one of these, I was like, what the heck is this? Why are they opening those parentheses? Then it turned out that the TI-83 was supposed to be more of a teaching calculator. It wasn't supposed to be so user-friendly. And I was like, oh, wow. Doesn't that defeat the purpose of a calculator? Or is that just my silly common sense? So parentheses, -2, ln 3. If I don't close these parentheses, I'm going to get the wrong answer. -2 ln 5. Close, close. Divided by open. ln 5. Close. If I don't close it, it's going to give me the wrong answer. -2 ln 3. Close, close. Enter. I think this one said to round to the nearest thousandth. Tenths, hundredths, thousandths, that's 3 decimal places. Okay. The other day a student asked, could they round it to 4 decimal places if they wanted? Well, I mean, you could do that, but it's going to count it wrong. Okay? So 9.21, will I leave it as a 4 or round that 4 up to a 5? 2, 1. Let's see. The number after the 4 is a 3, so leave it as a 4. That's right. And it was a positive, right? Yeah, positive 9.214. Hmm. 9.214. Any questions here? We're solving exponential equations where there's not a common base. Okay? Ones with a common base are generally easier. Okay? And you don't wind up with these what's called irrational numbers. They're decimal numbers that never repeat, never terminate. Are we ready for the next one? Problem number 4 has that irrational number e in it, which is 2.71828182846 ... It keeps going and going. E to the negative 0.96. Is that a t? Yeah. The variable here is a t rather than a x. Okay. Equals 0.93. Well, we saw how to do these a week ago if there were an e on each side. If there was an e on each side, you would just write an e equals e and then say, okay, the bases are the same, so the exponents have to be the same. Well, since there's not an e on both sides, we're going to follow that same sequence of steps that we used up here. Number 4 looks terrible, but it's easier than the other ones. When you stick ln in front of each side, if you remember a rule that we had at the end of class the last time, on that assignment over logarithms, what happens to e's and ln when they're side by side? If you have an ln and an e, like right here, they cancel out. This one's actually going to work out pretty nice. We canceled out that ln and e over here on the left. Then we just have a negative 0.96t equals ln 0.93. It took a lot like physics calculations and stuff here. And you're going to take physics. Now, all we have to do to get rid of this t is what? This is negative 0.96 times t. So what will cancel all of that out? Am I going to divide both sides by negative 0.96? Or am I going to add? Divide, yeah. Divide both sides by negative 0.96. Divide by negative 0.96. To patch this into the calculator, you don't need a lot of parentheses. There's just one number on top, 0.96, no, 93. And on the bottom, there's just about one number, negative 0.96. But what you do have to do, if your calculator is like mine, is close this parenthesis right here. If you don't close that parenthesis right here, it's going to give you an error, I believe. And let me punch it in wrong. Negative 0.93, if I forget to close those parentheses, divided by negative 0.96, look what it does. Non-real answer. So you might be tempted to come over here and choose the answer B. The solution is not a real number. What it really means is you messed up. Okay? So don't choose answer B. Instead, let me punch it in correctly. ln 0.93 close parentheses divided by negative 0.96. Now I won't get an error. I'll get, let's see, 0.075594. How are we told to round this? Oh, on this one, 4 decimal places. So, t is approximately 0.075. That second 5, are we going to leave it as a 5 or make it a 6? What will I do with this? 6? Yeah, the digit after the 5 is a 9. So, round up. Oh, I wasn't sure my screen was. Here. 0.0756 is how I would round it. The thing that's tricky about punching this into your calculator, make sure that you have those parentheses there. And I don't know what, I guess I must have just touched my pen. This is not a point right here. Okay? I don't know what that is. Let me see if I can write it in such a way. There. Well, I think I've successfully made it look worse. But that thing right there is not a decimal point. I don't know what happened there. So let me punch in 0.0756. 0.0756. Check your answer. Those 4 problems are the exponential equations. We do 2 types of equations in this assignment. Exponential. Now we're going to look at some logarithmic equations, which that's how we started off our discussion of logarithms on Thursday. Let's see. If I scan back, this is stuff we were doing. We were solving, let's see. Looking back at, no, that was, oh wait, not Thursday, Monday. Looking back at Monday's lecture over logarithms. Problems 1, 2, 3 said solve the logarithmic equation. To solve it, you want x equals a number. So you're going to have to cancel out the logarithms using this idea of the common base. Okay. This rule and this rule. This rule right here, we're going to be using when we do problems 5, 6, 7, 8, 9, 10. Okay? Let me show y'all what I mean. Oh wait, let's write down the problem. Problem number 5. It says solve for x. Log base 3 of 2x minus 4 equals another 3. Oh, geez. Since there's 2 3's, I'm going to write the small 3 in red. I've already written it in black, but I put red over it just to make it blurry. Okay, I don't know that I'm actually helping matters here, but I want to be able to talk about the 2 3's. There's the small 3 and then the big 3 here. It would have been a better example if maybe this had been a 3 and that had been a 5 or something, but it doesn't work out like that. Well, in order to solve this equation, we got to get the x by itself. In order to get the x by itself, you've got to cancel out this logarithm. So it goes back to that, where is the rule? I was going to try to mark the page. One of the first things we did on Monday, if you have the same big base and small base, they cancel each other out. We had a problem, number 4 on Monday, where it just looked like that. Log base 5 of x equals 4. To solve for x, we put a big 5, so it would cancel out that small 5 there. Here we're going to do the exact same thing we were doing there. To cancel out this log base 3, I'm going to put a big 3 on each side. And then since we have the same number here and here, all of that cancels out, leaving just the 2x minus 4. Now on the right, this looks sort of messy. Let me write it the way, this red 3 is the base now. This black 3 is an exponent. Okay. So that's the equation we're trying to solve for x. I would multiply out 3 cubed. Don't say 9. 3 times 3 times 3. 3 times 3 is 9 times 3, 27? Yes? Okay. And now, divide both sides. No, not divide. What am I going to do to solve for x? Before I divide by 2, I need to add 4. So we have 2x equals 31. And divide both sides by 2 to get 31 over 2. 31 over 2. On these problems, you usually have an option that says something like either not a real number or empty set. That would happen if you wind up with a negative number after the logarithm. Okay? And I'll demonstrate that in a moment. We can't take the log of a negative number. If you hit, it doesn't matter what type of logarithm. If you hit a logarithm key and then put a negative number after that logarithm, it's going to say error, non-real answer. Okay? If you find yourself choosing that, you probably messed up. Okay? Number 16. Number 6. Log base 4 of x. Let me write this one down. Log base 4 of x plus log base 4 of x minus 6 equals 2. Well, I always try to look on the bright side. Now I'm looking on the bright side that they didn't have the 6 and the 2. They didn't randomly make all of those numbers 4, where we'd have too many 4s. And on Monday's class, we discussed condensing logarithms. And I was just looking through we expanded the logarithms, the way you separate them at addition and multiplication and division. You separate at multiplication and division. And this one, let's say this one right here. To expand it, the stuff in the bottom has a minus in front of it. The exponent goes in front of the letter L. You separate at multiplication and division, so there's 1, 2, 3 logarithms. Then we started going backwards, and once we started going backwards, I wrote out number 12. This is called condensing them, where we go from 2 logarithms to 1. Notice you don't subtract the 26 and the 15. If there's a minus sign in front of the logarithm, then that stuff goes on the bottom. And then 11, 12, 13, 14, 15, 16, 17, we were able to do without writing it out. So I don't have notes over that here. It was just, you looked at the problem and condensed it. That's what we're going to have to do right here on number 6. We know how to solve a logarithmic equation if there's one logarithm on the left and a number on the right. So we're going to make problem 6 look like that. Condense these 2 logarithms so we have only 1. To condense it, you write log base 4, and then ask yourself, will there be a fraction bar after the logarithm? Well, if this plus had been a minus, there'd be a fraction bar. But since there isn't, you just say x times x minus 6 equals 2. What we've done is rewrite it so it looks like problem 5. By that I mean 1 logarithm on the left, 1 number on the right. If you're going to solve a logarithmic equation, you must have it written in that form. Just 1 logarithm on the left, a number on the right. When you do that, you can then cancel out the logarithm by putting a big 4, whatever that base is, all of that cancels out. And once I cancel that out, I have an x squared minus 6x on the left. On the right, this is a 4 squared, don't say 8, 4 times 4, 4 squared, that would be 16. And then we're at something we haven't solved for a while during class. We have a quadratic equation. That was some of that very first stuff we did. To solve a quadratic equation, you need a 0 on one side, and then either factor or use the quadratic formula. Well, these are all factor. So x squared minus 6x minus 16 equals 0. Let's see. Numbers that multiply together to give 16. 1 times 16, 2 times 8, 4 times 4. Which pair of numbers do you think is going to work out correctly to give me that middle term there? 2 and 8. Now, in order to get a negative 6, how should I arrange my signs? I want a negative 6. Oh, I think if we put the plus 8 and the minus 2, the positive minus 2, that would give me a positive 6. I think it's the other way around. If we make the 2 positive and the 8 negative, then negative 8x plus 2x gives the negative 6x. But you might have been getting ahead of me because once I set these to 0, but once you do this, it's going to be negative 2 and positive 8. Okay. Negative 2 and positive 8. If you punch both of those numbers in, you're going to get a error, or it's going to say wrong. If you punch in negative 2, 8, okay, it doesn't know what you did wrong, but this last step here that it says check your answer, maybe it would have been better if instead of saying check your answer, it had said make sure you're not getting the log of a negative number. Looking back at the work here, this negative 2 cannot be an answer. Because if you put a negative 2 in for x, you get log negative. In general, when solving these logarithmic equations, just generally knock out the negative answers. Okay? So mark out the negative 2. And we only have one answer, 8. Now, why are we knocking that out? Because you can't have the log of a negative number. If I try to punch in log negative, that's when it gives me that error screen, non-real answer. Okay? So all of these will have answers, but you might have to knock out one of them. So let me remove the negative 2. Okay. Y'all caught up? Number 7. Log. Hey, it just says log. It doesn't have one of those little bases. Do y'all remember what base we assume it is if it just says log? 10, yes. So we're going to pretend that there's a little 10 written down there. That's the base. Log 4x plus 6 equals 1 plus log x minus 1. to solve a logarithmic equation, you must ultimately have it written with one logarithm on the left, a number on the right. If you have two logarithms on the left, you've got to do the little condensing rule to get it down to just one. Well, number 7 has one extra step that none of the others did. We don't just have the number by itself on the right. What am I trying to say we're going to need to do to this to get that number by itself? Well, we need to move that over. So that's going to be, instead of a plus log, it's going to be a minus log once we move it to the right. No, to the left. Log 4x plus 6, then a minus log x minus 1 equals 1. So you put the two logarithms on the left, and then we're going to do that condensing stuff over here. You write log and ask yourself, okay, to write this as just one logarithm, will there be a fraction bar after the log? Yes, because of this minus right there. Okay? Like up here, if this had been a minus, there would be a fraction bar instead. So we have a 4x plus 6, that goes on top, and the x minus 1 on the bottom. Don't let the fact that there's a fraction scare you too much, because it's actually going to work out pretty nicely. Remember, since there's not a little base stated here, we assume it's a 10. So what big number do I need to write that'll cancel out that logarithm? 10. And it's going to look bad because we have the fraction. You have a 4x plus 6 over x minus 1 equals 10 to the first power would just be 10. And now we solve that equation for x. To do that, when I have just fraction equals fraction, what I like to do is just cross multiply. It'd be 10x minus 10 equals 4x plus 6 times 1 is just a 4x plus 6. We solved some equations like that at the beginning of the semester, second or third week, I believe. Third week. Now, I'll isolate the x by subtracting the 4x. 10x minus 4x, 6x. 10 plus 6, is that a 16? Then divide both sides by 6. If this were on a test and you type in 16 over 6, it's going to count it wrong completely. Whereas really, I wish it would just take off just a little bitty bit. Why? Well, what can I do to reduce that? What can I divide both of those by? Yeah, if I divide both of those by 2, I get an 8 over 3. That's my answer. Okay. I look through, when you take tests, I go through looking at each test. Since everyone's test has different problems and is in a different order, I can't just look and see which problem might they have not reduced and stuff. I go through looking for stuff like this. If you find yourself reviewing or looking back at a test you took and you notice, oh wow, it counted it completely wrong and all I did was I didn't divide or reduce the fraction, let me know. I'll look through and try to catch these, but as the semester progresses and more people wait to the very, very end to do the work, I just don't have time to, catch every one of those things like that. This is not a real easy, user-friendly thing that the teacher can look and see. Oh, wait, all they missed was they just didn't reduce that. No. It takes a lot of clicking and searching to find those. So 8 over 3. Okay, number 8. Let's see. Log base 6 of x plus 8 plus log base 6 of x minus 8 equals 2. Well, this one's already written with the number by itself, so we don't have to move anything around like we did on the other. But we do need to condense this down to just one logarithm. When I'm condensing the logarithms, I ask myself, should there be a fraction bar after the logarithm? No, because of this plus. If there'd been a minus there, there'd be a fraction bar. So it's just x plus 8 times x minus 8 equals 2. Let me see if I can make it a little bit bigger. Okay. Now let's cancel out that log base 6 by putting what number right here? That's 6. And here this x plus 8 times x minus 8. Go ahead and FOIL that out right now. It would be x squared, then a minus 8x, a plus 8x, and a minus 64 equals, on the right, this is 6 squared, don't say 12. 6 squared is that a 36? 6 times 6. And the 8x's are gone, right? Negative 8x plus 8x. And this is a quadratic equation because there's an x squared. I think probably the easiest way to solve it is just to write it as x squared equals a number. If I move that 64 over here, what number would I get? 64 plus 36, is that giving me 100 here? So x squared equals x squared equals 100. Can y'all tell me what the solution for x is? X equals 10. 10 times 10, you just take the square root. Now be careful. Under normal circumstances, you would say x equals plus minus 10. But why am I not listing the minus 10? Well, we can't take the log of a negative number. Like this one over here, we had negative 2 as an answer, and we had to mark it out. So just take the positive answer. 10 squared is 100. Okay? I just take the square root of that. So let me type in a 10. Any questions? We have 2 more we need to get through. Oh wow, number 9, this looks different. The way it just says log, log, we haven't seen any like that. But it's actually easier than the other ones. That's log base 9 of log base 9 equals 0. Oh, wait. Log base 9 of log base 9 of n equals 0. Let me lift this up. This one's different from the other ones, the way it says log, log. Okay? You might here it doesn't say log 6, log 6. Well, this is just going to involve a lot of canceling. I'm going to start off trying to get the n by itself. First thing I'll do is cancel out this black log. I'd put a black 9 here and here, and that's going to cancel out all of that, leaving me just the red log base 9 of n. Now be careful, don't say 0. What's 9 to the 0 power? We had that rule about 0 exponents from a week ago. Anything to the 0 power is 1. So that 9 to the 0, we write as a 1. We're trying to get the n by itself. So repeat it. What number will I put right here that'll cancel out this red log base 9? Another 9. So all we're left with is the n, the red n, equals 9 to the first power is just a 9. So this answer here is 9. Well, you're just sort of canceling out those logarithms. 9. And then problem 10, it ends up where we started with. This one is like problem 5. Let me write it down. No, problem 6. This is problem 10. Log x plus log x minus 15 equals 2. Log x plus log x minus 15 equals 2. Well, the two logarithms are on the same side, so we'll condense them down. Will I need a fraction bar? No. Oh, wait. Let me switch. I won't need a fraction bar because of this plus. So it's just going to be log x, parentheses x minus 15 equals 2. This is one of those where it just says log and doesn't state the base. What base do we assume is there? 10. So I'll put a 10 on each side. And then what do we have? X squared minus 15x equals 10 squared. What am I going to put right here? 100. 10 times 10. Is a quadratic equation. So move the 100 over. Minus 100 equals 0. And we factor this. Let me think. What numbers multiply together to give 100? I think I'll write them over here. 1 times 100. 2 times 50. 4 times 25. If I get to the pair that you think works, call it out. 5 times 20. 10 times 10. The 5 times 20. Okay. So let me draw my two sets of parentheses. X and X. 5 and 20. Since the second sign is minus, we have a plus and a minus. How should I write it to get a negative 15? Where should the plus go and where should the minus go? Get a negative 15. Yeah, that's one of each. Second sign is minus, so 1 plus and 1 minus. How would it, to get a negative 15? You would need the bigger number to be negative. If I put the negative there, we'd have x squared, and then a negative 20 plus 5 gives a negative 15, then minus 100. So we have it factored correctly. But now the signs are about to change, right? Once you set each one of these to 0, we get x equals negative 5. And x equals what? 20. Be careful, we're not going to put both of the punch in both of those answers. Which one are we going to mark out? The negative 5. You can't take the log of a negative number. So only 20 is our answer there. Okay. And if that seems familiar, I think it's just like problem number 6. Different numbers, of course. Am I right about that? Is it number? Yeah, log base 4. Okay, so number 6, it had a base of 4 rather than a base of 10. So the numbers worked out a little smaller than over here with our 100 and bases of 10. But okay, punching in 20. 2, 0. And I'm pretty sure this is where the new stuff ends. It's just review. Let's see, number 11. Oh, yeah, do y'all remember this? The domain of f is equal to the, what am I going to say there? Range of f inverse. The way they're switching the x and y's, the range of f is equal to the domain. Yeah. So that finishes that. And, I've gone through that. Gosh, there was something I wanted to mention and I don't remember, but I guess I'll call it quits right now. We'll just I'll stop the recording unless there's a question you want to ask that's recorded.